Lesson 2-4, Scatterplots, Correlation, and Regression. Objectives: develop an ability to construct a scatterplot of paired data. Analyze a scatterplot to determine whether there appears to be a correlation between two variables. This introduces us to the analysis of paired sample data. Let's start off with a few terms, make sure we're all on the same page. Correlation. Correlation exists between two variables when the values of one variable are somehow associated with the values of the other variables. Linear correlation exists when between two variables when there is a correlation and the plotted points of paired data result in a pattern that can be approximated by a straight line. And I'll show you more on that in just a second. But first, to do that, we need to know what a scatter plot is. A scatter plot is a scatter diagram, a plot of paired XY quantitative data with a horizontal x-axis and a vertical y-axis. The horizontal x-axis is used for the first variable x, and the vertical axis is used for the second variable y. Big thing here, correlation does not imply causality. Okay, so let's see what a scatter plot looks like. And here I went ahead and put in some data. There's a bunch of them. I think like 270. Yeah, 270. There's a bunch in here. Yeah, and I got this off of a data set from, there's 290 of them. 300. Okay, even better. So this is a big data set, 300. I didn't think you wanted to watch me type them all in, so anyway. Once you get your data in, you press on, and then you go to the graph, okay? And then we have shoe print, and we have height. I'm doing the wrong one here. We have weight. We have weight. Let's see what we got. Waist and arm. Waist and arm. Waist. Got a bunch of them in here, don't I? And arm. All right. So that looks at. All right. Now that looks like that may have some correlation, okay? That may have some correlation. And the scatter plot, the quantity, all right? And then, so that may have some correlation. Correlation exists between, okay? So that may have some correlation. And let's look at another one. This one here is weight and pulse. Weight and pulse. So let's draw another one. And, weight, weight, and pulse. All right, now look at that. That looks like the pattern from a shotgun, okay? So there's probably not any correlation there, okay? But, you know, it might be just kind of hard to look at them and tell. Let's try another one. Let's try another one. We got year and pennies here. So on graph, and down here we'll put in year. And over here we'll put in pennies. Whoa, what happened here? And I think I need to put pennies over here. There we go. How about that? Pennies in year. This graph is good. It tells us something. It tells us that if you look here, somewhere around 1985 or 84 or something like that, something happened. And in this particular case, something did happen. Before 1983, pennies were made with 97% copper and 3% zinc. After 1983, pennies were made with 2.5% copper and 97.5% zinc. Okay, copper weighs more than zinc. Okay, so tells a little story there. Now let's see here. We did that. Linear correlation coefficient, the second one, R. It's designated by the letter R. It measures the strength of the linear relationship between two variables. The computed value of the linear correlation coefficient is always between -1 and 1. If R is close to, if R is close to -1 or 1, there appears to be a linear correlation, provided the sample is large enough. There will be more on this in chapter 10. Table A5, you're going to need to know that, okay? That's where you're going to be able to tell, and I'll show you just a second about that. If there is really no linear correlation between two variables, the p-value, and this is another test, is the probability of getting paired sample data with a linear correlation coefficient R that is at least as extreme as the one obtained from the paired sample data. So let's check this R thing out. Let's check this R thing out. And here, shoe print. And in this particular one, you can see I've only got about five things there. All right. And we're going to do like we've been doing, on, graph, and then we got shoe print, and then what was the other one? Shoe print and height. All right. And now just looking at that, it would be really hard to tell whether or not there's a strong correlation there, just because, well, you only got 5 for one. And it's hard, and you know, you got one up here and one down there, and one up here and one down there, and you really can't tell, okay? So we need a better method. So let's go here. Let's go back to our data, and we're going to press Menu, Stats, and then Stat Calculations, and Linear Regression number 4 there. And then our X list is shoe print. Our Y list is height. And let's see, let's put it on D. We'll do it on D. We don't want to right over the top of our data, so let's click that. All right. So R is our linear coefficient, and that's 0.5913. Okay. Now that we've got that, we still really don't know. Okay, we still really don't know yet. We need to go to table 5. Turn in your books to table 5. And if you look, it says N, the first column is N, and go down to 5. And the next column is alpha equals 0.05. Well, underneath that is 0.878. So you've got those two numbers. And we'll go back to, and I'm going to draw us a little something here. Let's get this thing here, and I'm going to, where it's big enough. I don't have an arrow or a two-headed arrow on this thing, so I'm going to have to improvise a little bit. And we got this. See if I can get that fairly straight. That looks fairly straight to me. And all right, now here in the center is 0, and over here is -1, and over here is 1. And let's put some. All right. Yeah, I was doing better. All right, now, off the table 5, we got 0.878, so let's put right here. we'll say right in here is 0.878. And of course, we got negative 0.878. So we've got that. We went to our data, and we got an R value of 0.5913. Okay, so what does all that mean? Well, 0.878 or negative 0.878 to 878 is the no correlation area. Okay, and over here is your correlation area. And over here is your correlation area. Okay. This would be a strong positive correlation. This would be a strong negative correlation. This here is no correlation. So based on the 5 data, based on these 5 points, we cannot tell that shoe print and height are correlated. Okay, just based on those 5. Okay, and so here we couldn't really tell. And let's see here. P-value is the probability of getting paired sample data with a linear correlation coefficient R that is at least as extreme as the one obtained from the paired sample data. Okay, we'll talk more about that later. Only a small p-value such as 0.05 or less, or a 5% chance or less, suggests that the sample results are not likely to occur by chance when there is no linear correlation. So a small p-value supports a conclusion that there is a linear correlation between the 2 variables. Now, here's the thing. Okay, most statistical stuff, statistical packages give you the p-value, okay? And the table like on A5 is not really used very much anymore. So that's why to tell you. But you got to learn the one, and then you'll learn the other, and then you'll be good to go. And we'll learn more about this in chapter 10. Okay, and just so you know, the p-value for this, the p-value for this was 0.2912, which is 0.2912 is greater than 0.05. So again, no correlation. They would both give you the same answer. Regression. Given a collection of paired sample data, the regression line or line of best fit or least squares line, the regression equation is y equals b sub 0 plus b sub 1 equals x. All right. B sub 0 is the y-intercept. Okay, and b sub 1 is the slope. Okay, and if we go back to our data here, yeah, it gave us, okay, one for this, well, it does A and B. So here we would have 125 point something, 407, we'll just do 0.4. And the slope in this case was 1.727, 1.7. Okay, so you would write the equation as y equals 125.4 plus 1.7x. Okay. Well, let's go back. Let's go back for a second here. Let's go back. Let's see here. What if we didn't have, what if we had more? Okay, what if we had more? So let's go on graph. This time we've got 40. And what did we call them? We called them shoe 2 and height 2. So let's go to shoe 2 and height 2. All right. Well, I wonder what the R value is here. So let's see here. Menu, data, or statistics, distributions, I meant stat calculation. What if we went to linear regression here, and then we got shoe 2, and we got height 2. Okay, so what's our R value now? Our R value now is 0.81. So our R value now, R is 0.81. Okay, now, does that look like that might have some? Does that look like that might have some? So what you need to do is you need to go to table A5, and see what it says for 40, what the alpha 0.05 is for 40. Let's see here. Okay, and in this particular case, I think I got 0.312. Okay, so let's see here. Let's go back. I got, and then we'll just draw some. Let's see here. And I got negative 0.312, and I got positive 0.312. And my R is over here at 0.81. So I would say there is a strong positive correlation. Okay. Now, let's draw some line here. So we've got this, and it's really easy to draw a line. Menu, actions, analyze, regression, and to linear. Oh, so we got 0.80, 0.9, and 3.2. Well, let's compare that to, let's go over here. Oh, 80.9, 3.2. Good. All right. So pretty easy to do with the calculator. Real easy to do. Oh, that's the end. Great. Folks, you have a nice evening, and we will see you tomorrow in class.